Population is a group of individuals of the same species living in a given area at a given time. However, due to wide geographic distributions of certain species, the environmental conditions tend to vary, which could affect their survival. Different population patches of this certain species arose because of this condition. These patches are called metapopulations.
Metapopulation is a population that is made up of several local populations which is interacting with one another within a large area. Take for example these hamsters. Let's say they are of the same species. The question is, what are the conditions that we consider these local populations of hamsters a metapopulation? There are four conditions that could define a metapopulation. First, they form different patches within a large area. Take for example this, patch 1, patch 2, and patch 3. Second, there is a substantial risk of extinction. We demonstrate that by killing off all the species or removing the hamsters in this patch. Third, migration and recolonization occurs after extinction. That will happen when there is immigration from one local subpopulation and their immigration to the recently unoccupied habitat patch. What we have seen so far are processes under the metapopulation scale where the different patches interact with one another. The last condition is that population dynamics are not synchronized. This happens because populations within each patch have their own dynamics. That is, they have their own feeding and breeding routine and their own birth and death rates.
Sir, can you explain to us what metapopulation is?
Metapopulation consists of a group of population of the same species which are spatially separated, although they interact at some level. For example, the yellow-vented bulbul, this species, it has at least 3 races distributed in the Philippines. One subspecies in Luzon, the guyabier, one in Samarlete, Cebu, the Samarensis, and the Suluensis of Mindanao and Sulu areas. So these are the metapopulation of the species. Basically, they belong to the one species, Pycnonotus guyabier, but as I said, there are 3 races that are for the species Pycnonotus guyabier.
Metapopulation population persistence is a balance between extinction and recolonization, just like what you have seen with the hamsters.
The trumpeter swan, largest and rarest of the world's 8 swan species, was once a common nesting bird in North, West, and Central North America. It was hunted extensively by natives for food and feathers, and its numbers began to decline when a market developed in European settlements for its skin, feathers, down, and quills. The decline continued with the gradual loss of nesting, feeding, and wintering habitats, especially in the United States, to expanded land use. The trumpeter was rare or extinct in most of the United States by the early 20th century. Many thousands survived in the core range in Canada and Alaska, however, where populations have since rebounded. Trumpeter swans breed from central interior Alaska to the southeast coast and north to the Brooks Range in forested ponds and lakes. Since the mid-20th century, the population has recovered to roughly 25,000 swans, and now they're coming back to Oregon.
In this setup, the inflow of water represents immigrant species, while the outflowing water represents the species being extinct. If the rates of immigration are high when compared with extinction, it will function as a single local population. But if the local extinction is higher than immigration or colonization, no metapopulation will persist.
The change in metapopulation, defined as the fraction of habitat patches by local populations through time, can be defined as the difference between the rates of colonization, C, and extinction, E, and can be computed using this formula. The habitat patches of birds occur in diverse environments. Some patches may be small and some big. Other patches might be close to one another or too far from each other. Some patches might be heterogeneous and support various types of vegetations, while some may be homogeneous. Different characteristics of habitat patches affect patterns of colonization, extinction, and persistence.
Hi, I will now discuss about patch size, isolation, and habitat heterogeneity. Take for example this can. It represents a small patch, while this basin will represent a large patch. And these jackstones will represent the birds. What will happen if I throw them or they migrate into the small patch? As you can see, there are birds or jackstones that was not included in the small patch. Now, what will happen if I throw them on the large patch? As you can see, all of them occupy the large patch, leaving none behind. High species colonization is indicative of high species persistence and a low probability of extinction. To demonstrate the effect of patch isolation on extinction, colonization, and species persistence, we'll play a game of jackstones. Crap, it's too isolated. How?
The stars should be close to each other, so you won't die.
Oh, now I see. Like what you have just seen, high degree of isolation will lead to extinction because neither colonization or species persistence will occur.
Have you done studies or do you know of any study about the influence of habitat patch size and isolation on metapopulation dynamics of any bird species?
Um, well, we haven't done any studies about um, regarding to habitat patch and metapopulation of birds in the country, but I have known of few studies dealing with these topics, like population dynamics, but very few published studies have been done for the Philippine birds.
Can you describe the habitat patches of birds, specific or general, with regard to their size and degree of isolation?
Generally, in terms of habitat patch, larger birds would need larger habitats or territory. For example, there are studies for weeping eagle. They have determined the territorial requirement of a pair of an eagle. They estimated around 5,000 or more or less, depending on habitat patches, mountain areas, and vegetation cover. Pero generally, the larger the bird, the larger the territory or habitat would be compared to the smaller ones. Although smaller ones, they can specialize in a certain forest or habitats. There are species that specialize on structures. Some species may thrive on the ground, some others thrive at the center, and other survive on the canopy. So species have their own ways to survive in a certain types of patches or forests.
How is habitat patch size related to colonization, extinction, and persistence of the bird species?
As far as I know, in terms of habitat patch for colonization, so it depends on species. So, as I said, there are species that specialize on the strata of the forest to survive. Like I have said earlier, some species may survive on the ground, in the mid canopy, and then the upper canopy. But in terms of extinction, basically habitat patch play important role in birds extinction kasi syempre if the habitats shrink, population of birds or some birds may also get extinct because they have no home to live. So that's for the extinction. And also for the persistence of birds to live in that area, I think it's the same with extinction. What would happen with if habitat shrink? Some bird would also go extinct because there are birds that are specialists, meaning there are species that thrive on a certain mountain range or a certain elevation, and if the habitat patch of that certain elevation of a mountain disappear, definitely that species will also disappear.
How is the degree of isolation related to colonization, extinction, and persistence of the bird species?
In terms of isolation, think it has something to do with biogeography. Species, for example, species can easily, other species that travels a lot, like doves and other larger birds. They can fly certain distance and they can reach islands which they may colonize or not. But compared with other species like flycatcher, they can even cross sea barrier, so they tend to isolate in where they are. For example, an island, so they tend to stay there. And in some theory for isolation, they might tend to speciate on their own, given a certain enough time for them to become a species.
Can you describe the degree of environmental heterogeneity of the different habitat patches of birds?
So in terms of habitat patch, more heterogeneous forest is basically more diverse than homogeneous forest. So definitely there are more species in a heterogeneous environment than in an homogeneous environment or homogeneous forest.
The ability of the individuals to disperse between habitat patches is directly proportional to the spatial arrangement on the landscape occupied. The rate of colonization declines with increasing isolation, while the rate of extinction increases as the patch size becomes smaller. Persistence is then affected by the patch size and isolation of the species. When there is a high degree of isolation, it is more difficult for the species to recolonize after local extinction, therefore decreasing the persistence of the species. This is also true when the patch size is small. Since the population that can occupy that patch is small, it has increased chances of extinction due to random variations of birth and death rates. Persistence of a species may also be affected by increased patch size, since it increases environmental heterogeneity. Larger patches have the potential to be spatially more heterogeneous than small patches. As a result, larger patches may have habitat types that are not present in small patches. Such environmental heterogeneity is that when environmental conditions change, essential resources for a particular species might disappear quickly and totally for small patches than those with larger patches. Birds prepare to go back on a spring migration to the far north. This short-eared owl abandoned its breeding ground to spend winter hunting for field prey on the banks because it needs food. While the uplands lie frozen under a blanket of snow, making the food inaccessible, the lowland salt marshes remain snow-free, making the prey available. For the starling, Soil invertebrates such as earthworms are vital food resource. Each autumn, millions of starlings migrate south and west out of continental Europe. Birds come to UK from as far away as Siberia in search for mild climate. The northwest of England is rich in wetland habitats, and these attract hundreds and thousands of migrant birds during the winter months. The jay is an acorn specialist. In some years, the acorn crop fails over large geographical areas, forcing birds to move in search for alternative food supplies or risk starvation. Some birds switch habitat between seasons. The great crested grebe is a common breeding bird on well-vegetated lakes throughout England and Wales. As autumn turns to winter, the birds lose their spectacular head plumes and head for shallow coastal waters to hunt for fish in ice-free conditions. Whooper swans leave their breeding area in Iceland, pausing briefly at traditional stopovers in western Scotland before reaching their final destination. Birds that fail in their migrations inevitably perish. Migration is a very hazardous adventure, and many birds fall victim to exhaustion, starvation, bad weather conditions, faulty migration, or predation.
A homogeneous environment encourages migration and exposes the birds to its dangers, which may negatively affect their persistence. On the other hand, since heterogeneous environments discourages migration, it supports species persistence.
When the chance of extinction is independent in each local populations, the probability of metapopulation extinction declines. Since there are different rates of extinction between local populations, one population may persist even when the other becomes extinct. Therefore, this allows recolonization of the living local population after that extinction. This is called the asynchronous dynamics. Four levels of spatial aggregation provide an understanding of the role of population in the processes of demography, movement, geographic distribution, and evolution. A good example of this is the Galapagos finch. The populations of finches in the islands of Galapagos are widely distributed and isolated, thus forming metapopulations of the finches. Because of a long time of separation of these finches, they have adapted to their isolated patches and exhibited evolution, acquiring different phenotypes for different diets of the finches.